Good afternoon to all. In my previous class, already we have to discuss about the introduction regarding the solid edge software and how we are using the how we are constructing the two-dimensional diagram as well as the three-dimensional diagram by using these kind of softwares like either solid edge, LibreCAD, and different types of solids we have to discuss. And today we are going to start a new topic which is related to the section of solids, which means we have to previously studying about the different types of solids, and we have to directly project our solids into the first angle projections or first quadrant. Here we have to do some cutting process of the solid parts. After that we have to project that the remaining solid components into the projections of solids. So that is called section of solids. We have to project that particular section of solids into the either first quadrant or third quadrant. Most probably we have to select the first quadrant. Please anyone recall the previous class or previous session?
Sir, myself, previous class we saw about many types of solids like hexagonal, cuboid, and many more we saw. In particularly previous class we saw about projections of cylinder and the projection of pyramid with the angles.
Okay, super. Actually, in my previous class, we have to discuss about the projections of both the solids we have to discuss. One is for hexagonal prism and another one is for the cylinders. How we have to project this kind of solid components into the first angle projections we have to discuss. Likewise, we have to discuss about the section of solids. First, we have to take the some solid components. Like we have to today, we are going to take the one hexagonal prism, which is prism. So we have to cut some of the angles, like we have to maintain either 30 degree or 40 degree incline line. This is the axis line. So perpendicular to the axis line, we have to cut some of the solid components. Like we have to slice in that 30 degree of that particular hexagonal solids. So automatically we will get the some sections. So we have to project that sections into the either first quadrant or third quadrant. That is called there is a basic difference between the section of solids as well as the projections of solids. Okay. So likewise, we here the section of solids also we are having the both types, like we are discussing about the cone, and after that we have to discuss about the cuboid and cone and the cylinder. Likewise, we have to discuss about the pyramid and the prism. Okay, what are the solid components already we have to discuss. All these components are here also we have to project the section of solids also. Okay, so based on this hexagonal pyramid, this will be prepared or made by our easy students. They can do one small activities which is related to hexagonal hexagonal prism. Okay, please you can do the activities.
Good afternoon to all. Today we are talking about hexagonal prism. The hexagonal prism contains two hexagonal faces and 6 rectangular faces. It consists 12 edges and 16 corners. For that, we will talk about the 3D concept.
Actually, what basis today we are discussing about the DT based hexagonal prism. So that's why they have to prepare one chart which is fully based on our DT activities. How we have to select the prism from the different solid components and how we have to develop, and all one more students they have to do some actions.
And I tell about the external prism in the design thinking concept. In design thinking there are 5 stages first empathize. We observe that students find 3D shapes confusing in geometry. Many do not understand how 2D shapes convince into 3D shapes. The teacher explain the 3D object in 2D dimension in board, which all struggle to understand the students. Next, define. Now we want to make a 3D shape which is understood by all students. Idea: the 3D shape should be done by making charts, paper, and cylinders. 4 stages prototype. In 4 stages, we making the 3D structures by using chart paper, cardboard, and the scissors. In test, the prototype which is done in test is testing, which is capable to understand if students to understand 3D structures.
Actually, our students clearly explained. For example, we have to practically teach the component means students they are not able to understand the 3D imagination. So that's why they have to select the DT based empathize and they have to develop the model. After that, one of our students they have to discuss about the one problem which is related to the hexagonal prism. Actually, what is the problem today we have to discuss means a hexagonal prism of side of base 25 mm. Please can tell. So this is the base side. All the base sides we are having the 25 mm of diameter, or which means length, and 50 mm long. This is the axis length. So 50 mm axis length. One of its edge is HP, such that the base containing an angle of 30 degree to HP. So this is the basic problem. So from that basic problem itself, we have to do the practice regarding the projections of solids as well as the section of solids will be explained by our one of the students.
Good afternoon. I am Akash. I am here to explain the problem. Here, the given question is already explained by sir. So first we have to draw the XY reference line, and when the hexagonal prism is seen from the first quadrant, in the top view we could see the hexagonal face of the prism. This is the hexagonal face which is seen in the top view, which is marked in the horizontal plane with 25 mm dimension. And when we see from the front view, the rectangular face is seen, and the rectangular face is drawn in the top of the horizontal plane, which is vertical plane, with the dimension of 55 mm. Then the solid is inclined to HP of 30 degree. This rectangular face is inclined for 30 degree. It is inclined. So using the projections of this rectangular plane and this hexagonal plane, the projection of three-dimensional shape of hexagonal is seen here. Hexagonal prism is seen here.
So this is the basic problems which is related to the projections of solids. Only the candidate they can explain the how we are projecting the projections of solids, which means from the top view we have to see that the hexagonal face. From that front view we are seeing about the rectangular face. Then after that they are telling the angle inclination of the rectangular face, which will be 30 degree inclined to the HP horizontal plane. So that's why we have to incline that rectangular face into 30 degree. After that we have to project all these points, which is the inclination points as well as the top view of that particular hexagonal prism. We will get the somewhat inclination of both the hexagonal prism will be appeared in our horizontal plane. Okay, so likewise we have to explain the section of solids also. So we have to cut some of the parts, like here we have to cut this section. So automatically the above parts will be removed from the section of solids. So from that removed part will be shaded by using this kind of projection, that is called the section of solids. Okay, from the today's class, same likewise we have to cut the some 30 degree inclination line or cut section to the hexagonal prism. After that we have to project that section of solids into the first angle projections or first coordinate. Okay, so this is the basic problems which is related to the section of solids. Can anyone summarize the today's class what we have to discuss in our class?
Good afternoon, myself Anusatyan. Today we have learned a new lesson about the cut sections of 3D solids that we have learned in our last chapter. Cut sections means cut sections include the faces, the corners and edges and vertices of the 3D solids we have learned. And after that we have seen a problem from our last chapter on hexagonal prism. It's explained by our students from our class using a 3D solid object prepared by them.
Okay, good. Actually, today's our overall session will be an DT based how we are projecting the hexagonal prism into the first quadrant. In our next class, we have to see about the another section of solids which is related to the other solid components. Okay, thank you.